See how many things my computer can be doing at once. All right, so after looking at this last night, hopefully that helped you out a little bit. I know that whenever we first started it, you know, I was like, can't hear anything in class. Ah. All right, let me go take care of them real quick. You can't hear me? How's that? All right. Got them fixed. All right. So hopefully, as I said, you know, this once you had a chance to look at it and everything, you understood a little bit better. Let's take a look at the answers for page 5. Apparently, this wants to be on this side of me. There we go. All right, so I switched it so that I wasn't writing over here so that we could look at these at the same time. So 3-ethyl, 4-methyl heptane. If we number this way, we're going to get a 4 for the methyl. But if we number this way, we get a 3 for the ethyl. The 3 for the ethyl is a much better way to do it because they have the lowest number possible, and that's one of our requirements for when we do this. So there are 2 in the chain coming off of the 3rd carbon. There is 1 in the chain coming off of the 4th carbon. That's how we determine whether it's an ethyl or a methyl. Remember, meth is 1, eth is 2, prop is 3, so on and so forth. If we take a look here, we number 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. So if we number this way, we get 4 for the ethyl, but we can get a smaller one. We can get 3 for the methyl. It's all about getting that lowest number. So we would end up numbering it this way. So we get 3 for the methyl and 5 for the ethyl right there. Remember, when we do write these out, the ethyl comes first because of alphabetical order. And I think we did this one in class yesterday. And this one right here is kind of cool because what we've got is 1, 2, 3, 4, or 1, 2, 3, 4. So we've got 4, and we've got to decide whether we're going to give 4 to the ethyl or 4 to the methyl. Well, we choose to give the 4 to the ethyl because E comes before M, right? You're thinking, well, E comes before M, what does that mean? Well, if we have the opportunity to give 4 to 2 of them, and there's one that has, you know, a letter that comes before the other in the alphabet, we choose the one with the lowest alphabet number, or the one that comes first in the alphabet, to get the lowest number. And again, why do we do this? We do this because if we're making a book, you have to remember that a lot of this was done before the internet, and we have these ideas of endless information. If you're making a book that you're going to actually print out, and you know, these are going to sit in chemical laboratories, you can't have 16 different ways to name this. Otherwise, you're wasting paper, right? So they sit there and they came up with, all right, everybody's using this naming system. We're going to do this alphabetical thing. We're going to use these lowest numbers. That way we don't have all these extra pages printed. And whenever somebody's looking it up, they can find it quicker in the text. So that's why these rules exist. IUPAC stands for the internet. I gotta write it down. IUPAC, the International Union something applied chemistry. Wow, it's been that long. Let's look it up. That way I don't tell you guys the wrong information. International Union. What is the P? You guys could probably look this up quicker than me. International Union, oh, there, of course. International Union of Pure and Applied Chemistry. So that's what that stands for. And basically it's just over the years, scientists have sat on boards and stuff like that and said, let's do it this way. They're the ones that sit there and determine, you know, what we're going to call these new elements. Back in the day, whenever you discovered an element, like, you know, the scientists that made the discovery, or the laboratory that made the discovery, got to name them. That's why, like, right there you get like californium and berkelium. Both of those were discovered in, or actually made, because they're not natural occurring elements, in Berkeley, California. They said we can't do that, otherwise we're going to have all these ridiculous names whenever they run out of stuff, right? I mean, berkelium is a pretty ridiculous name. The two guys that were like, it's called berkelium after our university, you know, they were like so happy about that. But yeah, they were like, yeah, we got to figure out something better. All right, so I'm not going to be here Friday, so let's take a look at what I want to do about this class. And tomorrow is a weird shortened day or whatever. I'm sorry, this just popped into my head, and I think we should take care of it now. So what I think we'll do is just let you take the quiz either tomorrow, because you guys have all that, whatever, that personal project going on. I'll let you take the quiz either tomorrow or Friday. I'll put a video on for Friday dealing with organic chemistry. And then I'll probably make a lecture for Monday. Like the old ones where we had the recordings and stuff like that. I don't think I'll get to it by Friday though. If I do, I do. So let's just make sure we got this. Sure we got this week covered. All right, so apparently I still have to put that quiz in. We'll take this off, this branches and rings. Yeah, if you're coming in tomorrow, yeah, I don't know what that class is going to look like. I'm kind of calling today Friday, in a sense, because I'm taking Friday off, and tomorrow it's going to be a weird day. So we'll put that quizzes on there, and there will be a short video. And then Monday, I'll have a prepared lesson probably over rings. All right, that's good enough on that. Let's go back. All right, so we did show you, and you will be required to use different methods for this. So if I do that's such a long one, 2-methylnonane. See if I can get this a little bit clearer. There we go. 2-methylnonane, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2-methyl, 1, 2, CH3. There's our methyl. So this is a skeleton structure. To do the formal structure, all the terminal or primary carbons are going to have 3 H's on them. This one is a tertiary carbon, so that means it's bonded to 3 other carbons, so it only has 1 H. This one is a secondary carbon, so it has 2 H's. Basically, you look at the carbon, subtract the number of bonds, that's how many H's it has. 4 minus the number of bonds is how many H's it has. So we get that. And again, we can look at this as 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's basically showing a carbon here, a carbon here, a carbon here, a carbon here. Again, we know that this carbon right here has 2 hydrogens because 4 minus 2 is 2. This carbon here has a CH3 coming off the top of it. So this is 4 minus 3, which would then be 1 hydrogen on there. That's why this stick method works. And again, you could draw it out like this, or you could make it flat. In my mind, this and this are going to be the same 2-ethyl. 1, 2. Oh, this is funny. You could put these out like this if you wanted to. Oh, I just messed up. I knew I was going to mess up because I even brought my whiteout back here. This is probably my most prized possession, is my whiteout. CH3. And again, you could branch those out. This right here and this right here, in my mind, are considered to be the same type. That's the full structure. 1, 2, 3, 4 is the butane. 2-ethyl, 2-methyl butane. Somebody want to tell me what's wrong with that and why I laughed and giggled after I read it? Oh, come on, student of the month opportunity here. Hudson, have you been student of the month? Hudson? I don't think I have. You haven't? Now this is your chance.
I'm looking at it.
Why is 2-ethyl, 2-methyl butane? Why did I laugh whenever I started drawing this?
If you have ethyl on 2, you should branch from there. Like that should be like the main part of it.
Who is that?
Gavin Rung.
Nice. If we take a look, 1, 2, 3, 4, 5 is actually the longer chain now, right? So this actually would be 1, 2, 3, 3-methyl pentane. So this is the wrong name. Was I able to still draw it with the wrong name? Obviously, right? I was able to draw it. 1, 2, 3, 4, 5, pentane, 2, 3, methyl. So I was able to draw that with the wrong name. But again, why do we have this system where we are using these names? Because we can't print out every single different way we could call this thing. So we have this set. So let's try 3-ethyl pentane. I'm going to do it stick. 1, 2, 3, 4, 5. 1, 2, 3. This feels like a Batman symbol or something. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So there is 3-ethyl pentane. If we were to draw this out, 1, 2, 3, 4, 5. 1, CH3, CH2. This is not good. You should make sure that that branch goes to the C, but I ran out of room a little bit. It's like a bird with like carrying a fish or something, right? Ah. Questions on those? Oh, no, no, no. What did I ask you to do yesterday? I don't remember. Did I ask you to do some of page, whatever this is? Or did I just say do what you want?
You said do what you want, I'm pretty sure.
Man, that's pretty cool of me. What did you do?
I did page 7.
All of it?
Yeah.
Is there any ones that you had trouble with?
No.
Yeah, right? Once you start doing it, it's kind of easy. Are there any cool ones? Is number 5 cool or no? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're dealing with a pentane. 1, 2, 3. 1, 2, 3. Oh, it's going to be 3, 3 diethyl. Is that what you got?
I just got 3 diethyl. Why did you put double 3s?
So anytime you have di, that means that you better have 2 numbers, right? Because you got to describe where both of them are. So 3, 3. If you have di, you have to have 2 numbers in front of it. 1, 2, 3. So this is, did you put 2 or 2, 2? 2, 2. Did you put 2, 2 dimethyl propane?
No, I just put 2 dimethyl protein, but now I know what I did wrong.
All right, cool. Yeah. Draw structural formulas for the following. It's all the same. How about any? Wow, 10. Is 10 even cool? Well, let's do this one real quick. 1, 2, 3, 4, 5, 6, 7, 8. So we have dealing with an octane here. I don't think we can get more than 8 anywhere. 1, 2, 3, or 1, 2. So we got 2, 3, 4, 5, 6. Did anybody name this one? I think we might have to look that one up because we said we wouldn't have anything more than 4 really, right? Di, tri, quad. What is it? Anybody know?
I looked it up and I said penta.
Is it penta, you think? IU back 4, 5 methyls.
Is it just pent methyl?
No. So it is like when we use pent and stuff like that, that's a different system. So that's why I'm looking it up. We don't usually get that many of something. 5. So it's actually going to be a little bit difficult to look that up. I mean, I could go in there and look at my sheet because I probably looked this up last year, but let's see. If you guys have the ability to look it up too, you may be exactly right with pent, but all right.
On the answer sheet, it says pentamethyl.
Okay, then that's probably it. Yeah, pentamethyl. There we go. 2, 3, 4, 5, 6. Where's the answer sheet?
It's on today's lesson thing.
Really, I put an answer sheet to this.
Yeah, to the whole packet.
That's awesome of me, isn't it? I didn't even know. Cool. It doesn't have the answers to the test or anything on there, does it?
I haven't checked.
Hurry, check, right? No. Yeah, to tell you the truth, that's the way I feel like. I don't remember putting that on there, to tell you the truth. I'm glad I did, though, because now we know. 2, 3, 4, 5, 6 pentamethyl octane. They just got me so busy here. Going in circles. Let's take a look at this one. We should have known by just looking at this one. If I was a little bit smarter, I would have looked down and been like, yeah, it's probably penta. So if we take a look, hexamethyl, the hexa is referring to 6. So since we see 6 here, that means we should have 6 numbers out here. And this is just the same thing as the one above, except for we have another one, right? Let's do this in stick form. I'll let you try if you haven't already tried it. Just give it a real quick second of trying. So to make the octane, that means we're going to have 7 sticks. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8 points, right? 1, 2, methyl, 3 methyl, 4 methyl, 5 methyl, 6 methyl, 7 methyl. Cool. If you can do those type of things, you should be good for the quiz, the alkane quiz. Basically naming, talking about how there's single bonds. If I give you the number of carbons, can you tell me the number of hydrogens that would be there? If you're given this name, could you draw it and then rename it the correct name? 2-ethyl 3,4-dimethyl heptane. Heptane 1, 2, 3, 4, 5, 6, 7. 2-ethyl 1, 2, 3, 4-dimethyl 1, 2, 3, 4. So what was it, Gavin? Was it Gavin that said earlier, well, if you have an ethyl off of a 2, then that's going to be the longest branch, right? So instead of being a heptane, this is going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be an octane. Am I going too fast? No. 1, 2, 3, 4, 5. 3, 4, 5. Since I have 3 numbers here, that means I need tri. Every single one of those is a methyl. Put a little dash right there between the number and the letter. 3, 4, 5, trimethyl octane. All right, let's ramp it up. Alkenes. If we take a look here, we have alkenes. So alkenes are compounds that contain at least a double bond. So instead of calling, if it were ethane, if it were an alkene, what hybridization are these carbons undergoing?
SP2.
sp2. Yep. Instead of calling this ethane, we would call this ethene. Boom. All right. Everything else is the same. But as it says here, we're going under sp2 hybridization. So that means that every double bond we add, we lose 2 hydrogens, right? So this was C2H6 for the alkane. It's C2H4 for the alkene. So N, and then the number of H's is 2N for alkenes. Ethylene, that's given off by fruit as it's ripening, and it causes the other fruit to ripen. Or they can use it if they have fruit that's they picked early or whatnot, and then they can expose it to that and make it ripen. Some of you may have like some things like the little bags or like something that you put in with fruit that actually reacts with that ethylene, pulling it out of the bag. So it like traps it and makes a new product. And then it prevents the fruit from ripening more and more and more. Then it can basically, you know, preserve the fruit for a longer time. Propene. Now notice that in front of propene, we put a 1 here. There's only one place the propene can actually have that double bond, between 1 and 2. And then this would not be between 2 and 3 if we numbered this way, because we would always number that way. And here's the other cool thing is that this now takes priority with the lowest number. The other thing about this is this can change the longest chain, because the double bond has to be part of the chain that you're using. It has to be part of the longest chain. Right? Throw a bunch of rules in there, just like yesterday. So if we take a look here, if we're given this, we want to give this the lowest number. So it would not be 1, 2, 3, 4. I don't know why I put, well, I think I put 3 there because you don't count this as, it's not between the 3rd and 2nd. It's between the second and third. It always gets the lowest number that you can choose. So 2-hexene. 1, 2, 3, 4, 5, 6, 7. So we want that double bond to get the lowest number. So we get it with 3. And then we get 3, 5, 2 methyls, dimethyl. Talking about where the double bond is, 3 heptene. Alkynes, well, here we have a triple bond. What kind of hybridization are we dealing with this? One, two, right? So SP.
SP.
Thank you. SP. It's calling, instead of calling this ethane or ethene, we will call this anybody? Ethyne. Again, we don't need a number for this because there's no way that it can be anything different. This also has the name acetylene. You might have heard of that before, but for us, we're using the IUPAC name, which is ethyne. So 1, 2, 3, 4, 5, 6. Notice here, we could give this a 2, but we want to give the lowest number we can to this. So 1, 2, it's between 2 and 3. So that's 2, 1, 2, 3, 4, 5, 6. 2 hexine, 1, 2, 3, 4, 5. Coming off the 5th carbon is 1 methyl group. So let's draw these. Butene. 1, 2, 3, 4. Between the 1 and the 2 is an ene. So that is a double bond. Oh, I'm sorry. What should the Ines formula be? If this is CNH 2N, what would the alkyne be? How many H's per carbon?
Two.
What's it?
2.
It's still 2N, but what do we do to it? We can't leave it 2N, or otherwise it would be the same. For every extra bond, how many hydrogens do we lose?
2.
2. There we go. So an alkane is CnH2n plus 2. An alkyne is CnH2n. An alkene, I'm sorry, is CnH2n. An alkyne is CnH2n minus 2. Remember, every double bond we have, we lose an H. So there we go. 2-methyl 2-butene. 1, 2, 3, 4. It's between the 2 and 3. So there's my double bond. 1, 2. Right there is my methyl group. Or CH3, CH3. CH3, CH. Cool. Have some fun on that. It says 3-butene would never be found in a chemical catalog or directory under that name. In fact, it's the incorrect name. What should we call this?
Would it be 1?
Good. 1-butene. with this number from here to give it the lowest number. 1, 2, 3, 4, 5. I'm already naming it. I can't even. Yeah, 2-methyl-4-pentene would not be it because we would number it 1, 2, 3, 4, 5. So it would be 4-methyl 1-pentene. 2-butylpropene would not be it because it would be 2-methyl, right? 1, 2, 1 hexene. One butene 2,2-dimethyl would never be found in the chemical catalog because it cannot exist. Why can this not exist? Why can't that exist?
Is it because it's too many bonds?
You got it. If you drew it out without the stick figure, you probably would have seen that a lot quicker.
Wait, how can something be too many bonds? Is that a rule that we have?
1, 2, 3, 4, 5. Carbon is not in period 3, so it has to follow the octet rule. It can't use that D. sp3 is the most
Oh,
carbon can have. Yeah. And I didn't finish this. Let me do that real quick. So we have 1, 2, 3, 4, 5 bonds on that carbon. Not going to happen. Those look fun. Let's take a look here. Maybe tell me what they think about this one. What's going on here? 3,5-octadiene.
There are 2 double bonds.
Yeah, right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5. Octadiene. Down here. 1, 2, 3, 4. And we have another CH. But that's what we have going on. The di refers to 2. Enes refer to double bonds. The first one is between the 3rd and the 4th. Second one is between the 5th and the 6th. Fun stuff. I think that's good for today. You guys have some practice problems here, the alkenes and alkynes. If you have any questions, by all means, stick around. Otherwise, I'll see you for a short time tomorrow, or if you want to do the quiz or whatever. Basically, tomorrow I'll just answer questions, and then Friday there will be a short video. I don't know if I'll have time to record something today or not, but we'll see. If you have questions, by all means, stick around. If not, get out of here.
I just have like one question.
Yeah.
So like when something has a double bond and it's on the edge, is that still primary or is it like a secondary?
That's a good question. I would say I think it would still be primary, but I don't want to lie to you on this. Carbon. Since the terminal alkene is located at the end of the chain, the double bond is only connected to one carbon and is called primary carbon. There we go.
Cool.
Mm-hmm.
Mr. Jackson, on page 5, number 4, you like rearranged the numbers because you wanted a lower number on ethyl. Why do you want the lowest number on ethyl?
Because E comes in the alphabet before M.
So ethyl would come first, but does that mean it needs the lower number?
Which number?
Number 4. Because I just had it numbered. Oh,
Yeah, 3 is the lowest number we can get on that. So if you do it the other way, you're going to end up with 4 being, yeah. So you want to get the lowest number, which in that case would be 3. Make sense?
on ethyl because it comes first.
Give me 1 second. I'm trying to share this.
Okay.
Where is it? Oh, there it is. So if we take a look here. If we number this way, 1, 2, 3,
Uh-huh.
1, 2, 3. I'm sorry.
Wait, I'm on number 4.
Okay, number 4. If we number this way, 1, 2, 3, we have 3 being low. If we number this,
Mhm.
we have 1, 2, 3, 4. So this would be, if you went this way, this would be 5 ethyl, 4 methyl. And we can do it so that the 5 and 4 are lower numbers, 3 ethyl and 4 methyl. If we can use lower numbers, we do.
Okay. All right. That makes sense.
Q.
Okay. Thank you.
You're welcome.